Hi guys, welcome to Miracles Library. So in our previous class we talked about gas laws and we treated only Boyle's laws and Charles laws. That was what we just treated in our previous class. You can check our previous video, the gas laws explained part 1. You will see the video. So in this video today we'll talk about pressure law, ideal gas equation, Dalton's law of partial pressure, Gay-Lussac's law of combined volume, Graham's law of diffusion, and Avogadro's law. So in this video, these are the laws we are going to be talking about. So stay tuned, get your pen and a paper to write. So before we get started, I would love you to smash the subscribe button and turn on the notification bell so that anytime we post a video here on YouTube, you will be notified and you will get more of our educational videos so you can learn chemistry, physics, biology, or what, English. Now let's dive into the video. We'll begin with pressure law. What is pressure law all about? You can say that pressure law states that the pressure of a given mass of gas is directly proportional to its temperature at constant volume. That the pressure of a given mass of gas is directly proportional to its temperature at constant volume. That is pressure law. Now let's move to the second one, which is ideal gas equation. So now let's talk about ideal gas equation to know what it's all about. What is ideal gas equation all about? Ideal gas equation deals with the combination of all the three parameters of temperature, pressure, and volume. The three parameters: pressure, temperature, and volume. That is what ideal gas is. So let's take a look at this. P1 V1 all over T1 is equals to P2 V2 all over T2. This is ideal gas equation. The value of P is pressure, V is volume, and T is temperature. You can still say P1 is initial pressure, V1 initial volume, then T1 initial temperature, same as the T2. The T2 only is the P2 V2 T2 is final pressure, final volume, final temperature. So you can still say PV equals to nRT is also a ideal gas equation. These are what we call ideal gas equation, where P is pressure, V is volume, N is number of moles, R is the constant, and the value is 0.082 dm cube. T is the absolute temperature. So let's solve some problems on the ideal gas equation. Look at the example 1. It said if a gas exerts a pressure of 10 Newton per meter square to occupy a volume of 40 meter cube at 127 degrees centigrade, what will be the volume occupied by pressure of 20 Newton per meter square at 27 degrees centigrade? In our previous video, I told you that before you can calculate a problem on any gas laws or gas equation, the thing you have to do is to convert a degree centigrade into Kelvin. And converting it into Kelvin, you have to add 273 to the value of the degree centigrade. So in this case, now this 127, you have to add 273 to get the value of the degree centigrade, to convert it to Kelvin. That's the same thing you are still going to do to this 27 degrees centigrade. You add 273. That is the constant that we add. That's the value we add to convert degree centigrade to Kelvin. So whenever you want to solve gas laws, always remember to convert degree centigrade to Kelvin so that you can start your solving. So that is just it. That is all for this ideal gas equation, but we are still going to solve this equation. So let's know. So in this place now, you know the formula to use. What's the formula? P1 V1 all over T1 is equals to P2 V2 all over T2. Why? Because you can see 10 Newton per meter square, that is P1, 20 Newton per meter square is P2. What are we looking for here is the volume, the V2. Look at this, is the formula we are going to use, the equation. You know there are two ideal gas equations. P1, this one is the first one, then the second one is the PV equals to nRT, and that one is only when they ask you to look for maybe the number of moles you get. So similar to use depending on the kind of question they bring to you. That is just it. Let's solve. Where P1 is 10 Newton per meter square, I told you initial pressure is 10, initial volume is 40 meter cube, initial temperature is 127 degrees centigrade. As I said, 127 plus 273 to convert it to what Kelvin. Now the value is what 400 degree Kelvin. We have converted it. So this is T2 equals to what? Same thing here. It's P2, that is final pressure is 20. Therefore, this is the formula we are going to use. V2 equals to P1 V1 T2 all over P2. T2 was the value of P1 is 10, V1 40, T2 is 300, P2 is 20, T1 is 400. Then the value of V2 is equals to what? 15 meter cube. So that is just take note. This is very simple. Only if you understand that degree centigrade parts, converting it to Kelvin at first before you start solving your equation or your problems. So that's it. Take note of the converting degree centigrade to Kelvin. You have to add 273 to the value to convert it to Kelvin. So now what are we looking at? Let us see what we are looking at now. Hope you understand this one. If you don't understand anything, you don't understand here, please let me know in the comment section so that we can do a video on that and make it proper. Hope you are getting my point. If you don't understand something here, just try and send some comments. So now example 2, these are example 2. A certain amount of gas occupies 10.0 dm cube at 2 atm and 10 degrees centigrade. Find the number of moles present. R is equals to what? 0.082 atm. So in this place now we already know the formula we are going to use. The formula is equals to nRT. Why? Because here pressure is given, temperature is given, then R is also given, and it says find the number of the moles. So solution, PV is equals to nRT. Then making n the subject of formula, we do what? We divide both sides by RT. So that's what we did here. Then the value we got is n equals to PV all over RT, where P is what? 2 atm, V is 10 dm cube, R is what? 0.82. That's the normal value, the constant. Then T is what? 10 degrees centigrade. You add 273 to convert it to what? Kelvin. So now we get n equals to 2 times 10 all over 0.082 times 263. Answer equals to what? Answer equals to 0.0862 moles. So what we did in the other problem is what we also did here in this T. What did we do? We add 273 to the 10 so I can convert to what? Kelvin. So I hope it's very simple. If you don't understand it, just drop a comment for us so that we can do a video on that. So that's for here. We are done with this one. So now let's look at the next one. So as I said, in this ideal gas equation there are two equations. Take note. Now let's talk about Dalton's law of partial pressure. Dalton's law of partial pressure states that if a container contains a mixture of gases which do not react chemically, that the total pressure exerted by the system is the sum of all the individual partial pressure of the gases. So this Dalton's law, you can still remember it to this: P total is equals to PA plus PB plus PC. That is what they say. They said what? The sum of all the individual partial pressure of the gases, that is what the total pressure. So example, let's solve some problems on this Dalton's law of partial pressure. Example, we said if a system contains gases A, B and C which do not react chemically, find the total pressure of the system if A, B, and C has partial pressures of 10 Newton per meter square, 30 Newton per meter square, and 40 Newton per meter square, respectively. Solution is what? P total is equals to PA plus PB plus PC, which is the Dalton's law of partial pressure. P total is 10 plus 30 plus 40 equals to 80 Newton per meter square. So now we have an idea of what Dalton's law of partial pressure means. We have to look at what? We have to look at the Gay-Lussac's law of combining volume. Gay-Lussac's law of combining volumes is that when gases react, they do so in volumes which are in simple ratios to one another and to the volume of their products in if gaseous, provided the temperature and pressure remains constant. This is an example of the Gay-Lussac's law of combining volume. Example is what? 40 cm cube of carbon 2 oxide as packed with 60 cm cube of oxygen. If all the volumes of gases are measured at STP, calculate the volume of excess reactants and name the gas. So when you say that STP, the meaning of STP is what? Standard temperature and pressure. So this is the solution of the example. You say what? 2 carbon oxide plus oxygen produce what? 2 carbon oxide. Just look at it. Look at everything here. So the reactant in excess is what? Oxygen. The volume of excess oxygen is equal to what? 60 minus 40 equals to what? 40 cm cube. Just in this channel, we just bring back what you've read before. So now let's talk about what the Graham's law of diffusion. So just take note, in this channel, what we do is we just give you some, like, how will I put it, we just bring back what you've read, revision. So that's what we're doing here. So Graham's law states that provided the temperature and pressure are constant, that the rate of diffusion of gas is inversely proportional to the square root of its density, which is R is equals to what? 1 all over square root of E. That is Graham's law. So now note, rate of diffusion is equals to what? Volume all over time. When they say calculate the rate of diffusion, volume all over time, which is what? R1 all over R2 is equal to square root of E2 all over square root of E1. Since relative molecular mass is equal to 2 times density, then just revision. So let's move to Avogadro's law, which is the last law for this video. So what is Avogadro's law talking about? Avogadro's law is a modification of what? Gay-Lussac's law. It states that at constant temperature and pressure, equal volume of gases contain the same number of molecules, V. Take note of this. 1 mole is equals to 22.4 dm cubed, 6.02 times 10 raised to the power of 23 for all gases at STP. So guys, we have come to the end of gas laws. If you have any question, let me know in the comment section. If you love what I do in this channel, do me a favor by clicking on the subscribe button and turning on the notification bell so that anytime I post a video here on YouTube, you'll be notified. Thanks for watching. Bye. God bless you all. See you in our next video. Thanks for watching.